Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 5th, 2025, so about 4 days ago. It shows how to train an LLM web agent to match the performance of other methods using only 55% of the compute. The paper is titled, How to Train Your LLM Web Agent, a Statistical Diagnosis. And as we'll see, their approach provides a much-needed blueprint for training these agents efficiently. Alright, this paper tackles the high cost and complexity of training open-source web agents for difficult, multi-step tasks. So this first figure really shows their core finding on the MiniWob++ benchmark. On the horizontal axis is compute cost, basically, the total amount of work the computer does, and on the vertical axis is the agent's success rate. They compare two strategies. The blue line is pure supervised fine-tuning, or SFT, where the model just imitates an expert. The warmer colored lines represent a hybrid approach, which adds on reinforcement learning, or RL, where the agent learns through trial and error. The results are clear. This hybrid SFT plus RL approach is far more efficient. So to give you a better idea of what these benchmarks look like, this next figure shows some examples. The tasks on top are for MiniWob++. You can see they are pretty simple single-page interactions like dragging shapes, selecting a date, or sorting a list. In contrast, the bottom images are from Work Arena. These are much more complex, multi-page tasks that you might see in a real business application, like filling out detailed forms or placing an order in an online service catalog. Moving to the more challenging Work Arena benchmark, this table breaks down the performance on a per-task basis. The columns show the model's success after a few training epochs. An epoch is just one full pass through the training data. The key comparison is between continuing with just supervised fine-tuning versus switching to reinforcement learning using a method called group relative policy optimization. This is a technique that helps stabilize the learning process. The hybrid approach clearly improves performance, and on some tasks, like ordering a laptop, it even surpasses the powerful Llama 70B teacher model. This next table really provides the big picture comparison. It pits their hybrid model against a whole suite of others, including powerful proprietary models like GPT-4o and Claude 3.5 Sonnet. The results are split into the two benchmarks we discussed, Work Arena and MiniWob++. For each, they measure performance on both held-out goals, which are new objectives within familiar tasks, and held-out tasks, which are entirely new problems. This really tests generalization. Their hybrid model significantly outperforms its teacher on MiniWob++ and gets impressively close on Work Arena. So to achieve that impressive performance, this next figure shows how the authors optimize the training process. This grid of plots looks at different hyperparameters, which are settings you choose before training begins, like knobs on a machine. Each subplot shows a different hyperparameter, and the columns represent different amounts of initial supervised fine-tuning. The key takeaway is that the best settings change depending on the training stage. For instance, curriculum learning, where the model gets easier tasks first, is helpful when starting from scratch, but becomes less useful after more training. This next table really provides the big picture comparison. It pits their hybrid model against a whole suite of others, including powerful proprietary models like GPT-4o and Claude 3.5 Sonnet. The results are split into the two benchmarks we discussed, Work Arena and MiniWob++. For each, they measure performance on both held-out goals, which are new objectives within familiar tasks, and held-out tasks, which are entirely new problems. This really tests generalization. Their hybrid model significantly outperforms its teacher on MiniWob++ and gets impressively close on Work Arena. So when you put all of these pieces together, what you get is a really practical blueprint for training more capable open-source web agents. The key takeaway is that a hybrid two-stage approach, starting with supervised fine-tuning and then switching to reinforcement learning, is the most effective path forward. This strategy is what allows these smaller models to significantly close the performance gap with giants like GPT-4o, and to do it using far less compute. It's a robust, statistically grounded guide for making real progress on complex, multi-step web tasks. That's all for our AI Research Roundup. Thanks for tuning in.